Hello. Hello, everyone. So, what we are going to do first is we're going to take a look at this graph and we're going to try to decide which of the following stories best fits the graph. We have four potential stories here. A car is speeding up and getting faster over time. A car is slowing down and getting slow over time. A car is driving at a constant velocity over time, or the car is not moving at all. So based on this graph, this graph is a position versus time graph, I want you to decide which of the following stories best fits the graph. Is it that the car is speeding up and getting faster over time? Is it that the car is slowing down and getting slow over time? Is it that the car is driving at a constant velocity over time? Or is it that the car is not moving at all? Interesting. So we currently have about 16 people. We have 9 people who have responded to the warm-up question. So we are currently missing 8 more, 7 more, 8 more. For those of you just joining us, please look at the graph and answer the warm-up question. Which of the following stories best fits this graph? This graph is a position versus time graph. And I want you to figure out which of these stories best fits the graph. Is it A, the car is speeding up and getting faster over time? B, the car is slowing down and getting slow over time? C, a car is driving at a constant velocity over time? Or D, the car is not moving at all? We currently have about 13 out of 21 responses, so we are missing about 8. Wow, we are at 17 out of 21, so we're just missing 4 more people. Which of these stories best fits the graph? The car is speeding up and getting faster over time. B, a car is slowing down and getting slower over time. C, a car is driving at a constant velocity over time. Or D, the car is not moving at all. We are at 19 out of 22, missing 3 more warm-up answers. Let's take another 2 minutes maximum before we move on. We're at 20 out of 22, 21 out of 22. Let's take another 30 seconds for the last person to answer the warm-up question, please. Please. Okay. So which of these best fits the graph? So for those of you who are just joining us, for the couple people who haven't answered the poll yet, please do so. I want you to figure out which of the best following stories best fits the graph on screen right now. Where did everything go? Here it is. Okay. So first off, when we look at these graphs, let's first review a few key ideas here. The first key idea we want to review is that the slope of a position versus time graph is the velocity. So the slope of a graph tells us the rate of change of the graph. It tells us the rise over the run. It tells us how quickly the y value is changing every time the x value changes. And so the rate of change of a position versus time graph tells us how much the position changes every second, essentially. And that's just another way of saying velocity, right? Velocity measures the rate of change of our position over our time. And so that means that our velocity is the slope of our position versus time graph. So when the velocity of an object is changing, that means the object is undergoing some sort of acceleration. So basically, velocity tells us how fast we are going in a certain direction. So if that changes, then the object has to be accelerating. undergoing some sort of acceleration. If we combine points, the first two ideas, what we get is we get the third idea. When the slope of a position versus time graph is changing, that means that the object has some sort of acceleration. This is because when the slope of a position versus time graph is changing, right, the slope of a position versus time graph is the velocity. So is the slope, if the slope is changing, that means the velocity is changing, which means that the graph has to have some sort of acceleration. So basically in a position versus time graph, if the slope is changing, that means there is some sort of acceleration. Now, if we look at the graph on the right here, the one we examined in our warm-up question, the slope of the graph is changing over time. So initially, the slope, in other words, the rise over run, right, is pretty small. The rise over run is pretty small, right? The graph is not changing very much. Then after a few seconds, right, the slope gets bigger. And then a few seconds after that, the slope gets bigger. And then eventually at the end, the slope is pretty steep. So the slope is actually increasing over time. At the slope in the beginning, the object is not moving very fast, so the position is not changing very quickly. Every time it's around the middle, the slope is a little bit bigger. And towards the end, the slope is pretty steep, right? So that means that since the slope is increasing, that means the velocity of the object is also increasing, right? Right, if the slope is increasing, that means the velocity is increasing, which means that the object has a positive acceleration. The slope is getting bigger. So the key ideas you want to know here is that the slope of a position versus time graph is the velocity. When the velocity of an object is changing, the object is undergoing some sort of acceleration. So which means that when the slope of a position versus time graph is changing, that means the object's velocity is changing, which means that the object is accelerating. And in this graph here, the slope is increasing over time, which means that the velocity also has to be increasing over time, which means that the object has a positive acceleration. It's accelerating because its velocity is changing, and it has a positive acceleration because the velocity is increasing. Okay. So how does that help us figure out whether or not our object was speeding up or if it was slowing down? So before we actually want to think about whether or not it's speeding up, I think it's actually better to first look at what it means for an object to slow down. So first off, an object is completely stopped when its velocity is 0, right? If your velocity is 0, it just means you're traveling 0 meters every second. So you're not moving. What this means is that the closer our velocity is to 0, the slower it's moving, even if it's negative. And the farther away our velocity is from 0, the faster it's moving. So if our velocity is very close to 0, I'm going to give two examples right here. Let's say our velocity was positive 1 meters per second and negative 1 meters per second. So these are both pretty close to 0. These are both pretty slow. One of them, they both have the same speed. One of them is, they both have the same speed of 1 meter per second. They are both covering 1 meter every 1 second. The difference is that the positive one is traveling 1 meters per second in the positive direction, and the negative one is traveling in the negative direction. So the velocities are different because the directions are different, but the speeds are the same. And they are both pretty slow. They're not, 1 meter per second is not very fast. Now, let's say you're going very fast. So in which case you might be traveling something like 100 meters per second. And you could be doing this in the positive direction or the negative direction. Now, in either of these cases, 100 meters per second is very, very fast. Now, you may be going in the positive direction, you may be going in the negative direction, but regardless of which direction you're going in, you're going very, very fast. And you're going fast because the number here, the speed here, the value here is much bigger than 0. Whereas the value here, the value of the slope here, 1, is much closer to 0. So it's not necessarily about more positive or more negative, it's more about how close are you to 0. And so the farther away our velocity gets away from 0, so either it becomes very big positive or very small or very big negative, right? Like positive 100 or negative 100, that means we're going very fast. Or velocity is very small positive or very small negative, like plus or minus negative 1, plus or minus 1, that means our velocity is going to be very slow. It's very close to 0. So this is important because we don't want to be thinking about our acceleration as being whether or not our velocity is positive or negative, but rather how it's changing. Are we becoming very big, either in a positive or negative direction, or very small? Now, in this particular graph here, the car has a positive velocity. Why does it have a positive velocity? Is a positive velocity because the position is increasing, right? It's initially at the position of 0, and over time it has a position that's like this big. So its position is increasing. And if its position is increasing, that means the velocity is positive, right? The velocity tells us how much is our position is increasing over time. And so if our position is increasing, that means our velocity is positive. And that's also because our slope is positive here. And in this case, the slope is also increasing because we have a positive acceleration, as we just talked about in the last slide. So if my velocity is initially positive and it's becoming more positive, what that means is my velocity is going away from 0, which means my car is speeding up. The key idea here is we want to be looking at the slope of the graph in order to determine whether or not it's slowing down or speeding up. And not just the slope of the graph, we need to be looking at how the slope of the graph is changing. One big misconception that a lot of people, and I know a lot of people will have even now, or even during this class, is that because the graph is going up, this means that it's speeding up. And if the graph is going down, that means it's slowing down. This is not true at all. If the position versus time graph, if it's going up, this means that our velocity is positive because our position is increasing. That does not mean that we are speeding up. We could be slowing down, in fact, or we'd be going at a constant velocity, right? It's the direction of the graph itself does not tell us whether or not it's speeding up or slowing down. We need to be looking at how the slope is changing. Is the slope going towards 0, or is the slope going away from 0? And that is what we need to be looking at. So we're going to do we're going to look at a few graphs here, and we're going to analyze a few graphs, and we're going to try to figure out which of these graphs have the object speeding up and which ones have it slowing down. So in summary, we want to be looking at the slopes of the graph, and we want to be looking at whether or not the slopes are becoming closer to 0, so in other words, more horizontal, or if they're going away from 0, more vertical, right? And you gotta be looking at how these slopes are changing. Okay. So the first thing we're going to do is we're going to look at this particular graph here. And what I want you to do, I first just quickly want you to either take a screenshot of this or memorize it or burn it into your brain or just quickly sketch it out or I don't know, whatever. Just know what this graph looks like because I'm going to put you in your groups and then you're going to talk about it. And so you won't see this graph anymore. Remember what this graph looks like. Either draw it out or take a screenshot of it or whatever. And then what I'm going to do is I'm going to put you in your breakout groups, and I'm going to have within your groups, I'm going to have you decide whether or not the object in the graph is speeding up or if it's slowing down. And then I want you to just be able to write a very quick 1-sentence explanation of what your group said. So what did your group say? Is it speeding up or slowing down? And why your groups thought so? So very quick 1 sentence. So yeah. So once you have this graph sort of jotted down somewhere in your brain or on paper or something, I'm putting you in your groups now, and then I want you in your groups to figure out whether or not it's speeding up or if it's slowing down. All right, so what I want you to do now is I want you to start typing up what you and your group discussed. I want to hear what everyone's ideas are. So I want you to start typing up, and then in the next minute or so, start typing up what your group shared about what they think, whether or not it's speeding up or slowing down. Don't hit enter yet. We'll hit enter at around 120, 124 or so. So take about a minute to take a minute to write up what your group said. Did your group think he was speeding up? Did your group think he was slowing down? And then hit enter in about a minute or so. If your group has a reason for why they think it's speeding up or slowing down, I would love to hear that as well. Take another 30 seconds or so. Quickly write down what you and your group thought. All right, 5, 4, 3, 2, 1. Hit enter, 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 hit enter. Oh my god, so many cool ideas. Going down, decelerating, it's closer to horizontal, graph becoming less steep, more horizontal. Interesting. Okay. So I think the general ideas are pretty similar. The general consensus is that this graph here, in this graph here, we are actually slowing down. So let's talk about why in this graph we are slowing down. So the first thing that we want to recognize is that in this case, our position is increasing, which means that our velocity is positive. So for a lot of people, that might be like, okay, that's it, we're done. Because the velocity is positive, that means that we're speeding up. However, that doesn't mean anything. It just means that our position is increasing. What we want to think about is how quickly is the rate at which our position is increasing, how is that changing? Are we covering more position every second, or are we covering less position every second? So this is where we need to look at the steepness of the line, where we need to look at how horizontal is the line going, how horizontal is the slope, how much position are we covering every second? So in the first second or so right here, right, we're covering quite a bit of position here, right? We're covering quite a bit of position here in 1 second. And halfway around here, we cover a little bit less. And then right around here, we're barely covering any position at all. So our slope, the slope of our line here is becoming more and more, less and less steep. Towards the end, where it's almost horizontal at the end. So our position is increasing and our velocity is positive. However, our slope is getting less and less steep. It's getting flatter and flatter, which means that our position is changing by less and less every second. So even though our velocity is positive, we are actually slowing down. So we're going from a positive velocity to 0. And in this case, that means we have a negative acceleration. Our velocity is going from positive to 0. Anyone have any questions on this one? Towards the end, it's pretty horizontal. It's not moving that much. In the beginning, it's pretty steep. It's covering a little bit. And then in the middle, it's slowly changing. And so because the slope is getting flatter and flatter, that means our position is going to be changing by less and less every second. All right, since that one was clearly way too easy, we're going to do is we're going to go to a much harder one. That's right, much harder. Wow, this one's a lot harder. So the first two were actually, reasonable. This one I think is actually a lot harder and a lot wonkier. Also, you can't see the graph. That's great. That's great. Uh, okay, so this graph is going to be quite a bit more challenging because this one makes a lot less sense if you think about it. So once again, same process as the last time. I want you to just quickly either take a screenshot of it or jot down what the graph looks like, or remember what it looks like. And then I'm going to put you in your groups. And then when we come back, I just want you to be prepared to quickly just write out what your group discussed. So whenever you're ready, I want you to, whenever you're ready and you have your graph sort of recorded, I'm going to open your breakout groups again, and then I'm going to let you decide whether or not it's speeding up or if it's slowing down. Sorry, if I cut you off there, mid-question, you can, what was your question, Gabby?
Oh, I was just asking if we had a positive acceleration, then wouldn't it just keep going above zero and then we would need a negative
Yes,
acceleration?
yes, yeah, exactly. So if we had a positive acceleration, we would go from -5 to 0, 5, and then we would need another negative acceleration to bring it back down to 0. Yeah. Okay. So let's take a look at this graph here. I was planning on having you guys share, but I think one said I'll analyze it for us because there's one particular portion of this that I think was kind of interesting, and we'll take a look at it. So first off, let's think about some things that I think we can all agree on. So first off, I think we can all agree on that our position is always positive here. Right? It's always above 0. And I think another thing we can agree on is that the graph is going down. So that means that, which means that in order for a graph to go down, we would need a negative slope. Now what we need to do is we need to try to draw a little bit more from our understanding of how this graph is going. So first off, initially, the graph has a pretty steep slope. It's going pretty quickly. So every second it's covering quite a bit of position. In the next second, it's not covering as much. The slope is a little bit less steep. And then at the very end, the slope is almost parallel. It's almost completely horizontal. So the amount of position that we're covering every second is actually decreasing. So in this particular graph, we are actually slowing down. So essentially what's happening here is we are essentially moving backwards. But the rate at which we're going backwards is changing, right? Initially, we were going backwards by quite a bit, and then we started going backwards by less, and at the very end, we're barely going backwards at all. And until the very end, we are completely stopped. So we are just sort of decreasing. Our velocity is, we're slowing down. Our speed is slowing down. The hard part is when we start thinking about which direction is our acceleration going. A common misconception is that positive acceleration equals speeding up, and then a negative acceleration equals slowing down. However, this is not true. What a positive acceleration means is that our velocity is becoming more positive, and a negative acceleration means our velocity is becoming more negative. In this particular case, our velocity was originally negative. And so if we wanted to slow down, we need to bring our velocity closer to 0, which means we need to add stuff to it in order to become 0. So if we want our negative velocity to slow down to hit 0, we would actually need to have a positive acceleration. So that the thing is, right, when our velocity and our accelerations are opposite signs, when one is positive and one is negative, you're going to be slowing down, right? Because you're counteracting one with the other to bring it closer to 0. When your velocity is positive and your acceleration is positive, or your velocity is negative and your acceleration is negative, they're bringing each other farther apart, farther away from 0. So I think looking at the signs of your positive and acceleration and the velocity, the acceleration and velocity, looking at how the signs interact with each other can also clue you in on whether or not it's speeding up or slowing down here. So in this case, this actually has a positive acceleration because our velocity is going from negative to closer to 0. So it's going to keep adding stuff. So this graph was, I would say, definitely a little bit harder. The next graph, I think, is probably going to be the hardest one. So what I want you to do now is I want you to, once again, within your groups, just remember what the graph looks like. And then within your groups, I want you to decide whether or not the object is speeding up or if it's slowing down. So this one is probably the wonkiest one here. And this one, this graph is actually speeding up. So why is the object speeding up here? This is where we need to start comparing, once again, the steepness of the slopes. And we need to start looking at how much position we're covering in how much time. So in the beginning here, we're covering a very small amount of position in a lot of time. In the end, we're covering a lot of position in very little time. So we're moving quite a bit faster here compared to here, right? If we also look at the slope towards the end is a lot steeper than the slope in the beginning, which means that when the slope is a lot steeper, it means that we're moving a lot faster. When our slope is a lot less steep, it means we're moving a lot slower. Our velocity is closer to 0 when our slope is more horizontal. So basically, the steepness of the slope helps determine how fast an object is going, and the less steep the slope is, the slower it's going. Now the question is, what is our acceleration here? Our velocity this whole time is going to be negative because our position is decreasing. But because we are speeding up, our acceleration is also going to be more negative. So we're almost trying to amplify our velocity. We're trying to make it go even faster. So in this case, our velocity and our acceleration are both negative, which is kind of interesting. Okay, so this pretty much is a quick summary, I guess, of how position and time graphs look like when you have some sort of acceleration going on. For the rest of the period, we only have 9 minutes left. Okay, so for the rest of the period here, here's what I'm thinking. The next assignment we are going to start is called position versus velocity graphs. I'm going to link it in the chat right here. So we only have a few minutes left, so I'm thinking what we'll do is we'll just try to maybe finish the first question, since the first question is pretty much what we just did. So we're going to start that. You can make a copy of it with your group or something. And then we'll bring everyone back around 109. So the assignment itself, we're going to be looking at a lot of different graphs. We're going to try to basically try to analyze what each part of a graph might mean. As far as the due date, I don't have one set yet. I'll keep you updated on it. But yeah, for the rest of the period, let's see if we can finish question 1, since we did most of it just now. Yeah. Okay, I'm gonna put you in your groups again. If you have any questions, let me know. I know we don't have a lot of time left, but I'm thinking we can at least finish the first question at least. Okay, so it's 1:10 now. Okay, so no homework because we're gonna keep working on this on Friday. So you don't have to keep working on it in the coming few days. What you should work on though are any revisions for any stuff, anything that you have submitted and I've given you feedback on, you can / should revise them. Especially since quarter grades are, I mean, I believe the quarter ends this Friday, which means quarter grades will be coming up very soon. So I would highly recommend you get everything in by then. So submit anything revisions you have or any incomplete assignments or anything like that. If you have any questions for me about any assignment or if you want to, ask me something else, you can always come to office hours or just email me or something. Other than that, you are free to go and I'll see you all on Friday.
Thank you.
Thank you.
Bye. Bye.
Thank you.
Bye.